Okay, so this is the second day of videos for those of you who have to be absent for breaking down the walls. Today we're looking at limit ad infinity. And what does it mean to take a limit going to infinity? It means that we'll have a function, let's say we have 3x squared over x squared plus 1. And when I say that I want to take the limit of this function when x goes to positive infinity, what I want to see is what happens with this function when the values of x get larger and larger. Whereas when I do the limit when x goes to negative infinity of this same function, 3x squared over x squared plus 1, I want to see what happens with the function when the values of x get more and more negative. I have to be able to do limits three different ways: numerically from a table of values, graphically, that is from the graph, and then algebraically by paper and pencil. Numerically and graphically, you're going to probably rely on your graphing calculator to act like if I had a graphing calculator. I'm going to call some pictures that I already took. So I'm going to start by showing you this is what you would have to enter into your calculator, right? The function 3x squared over x squared plus 1, you enter that into the y equals 1. And then you can go into the graph, you can go into the table to see what it looks like. So I'm going to go into the table, okay? So I took a picture of a table that I had done. And this is a picture in which what it shows is that the inputs that I plug in, 1, 15, 137, 1795, we're getting larger and larger and larger. This mimics that x goes to positive infinity. In the meantime, I have to look to see what happens on the y-axis, what are my outputs. Careful, we already know the calculator lies. At 1795 is displaying 3, but it's really 2.99999. I can see that these values are getting closer and closer to positive 3. So I would conclude that numerically, I can see that the limit when x goes to positive infinity of 3x squared over x squared plus 1 is equal to 3. If you wanted to do the limit going to negative infinity, all what you would have to do is make a table of values in which the numbers get more and more negative and see what would happen with the outputs. When I'll let you do that, I want to warn you that the limit going to positive infinity and negative infinity do not have to be the same necessarily. Sometimes they are, sometimes they are not. But don't trust that just because you have one, the other one is already done. That's how you do limits numerically. Very, very easy. How do you do limits graphically? So how are you going to be asked to do a limit graphically? Okay, so in that situation, a graph of the function will be given to you. So either one from the book or one from your calculator. Let me insert a picture from the calculator. And let's see. This in here is the graph of the same function that we're messing around with. This in here is the graph of, this is f of x is equal to 3x squared over x squared plus 1. What does it mean, for instance, to take the limit when x goes to negative infinity? It means to check what is the graph doing when you move more and more to the left. This is when the values of x get more and more negative, and you're trying to see what's going on with the outputs. You can do that by pressing the trace button, see what kind of outputs you get. You can also just look to see where the values get getting closer and closer on the y-axis. You can see in here it seems to be 3. You can see also the value going to positive infinity was also 3. So I'm going to write something I didn't know before. I'm going to write that the limit when x goes to negative infinity for this function 3x squared over x squared plus 1 is equal to 3. Now, there is something really cool about this. It's the visual interpretation of these limits. I want you to see that this function has a horizontal asymptote at y equals 3. That's the equation of the asymptote. That means that what I found in here is the asymptote for this graph, the horizontal asymptote. I'm going to abbreviate it as HA, horizontal asymptote at with equation y equals 3. So in general, something cool in here. If you want to figure out horizontal asymptotes for a function f of x, what's the process? What do you need to do? You need to take the limit when x goes to positive and or negative infinity of that function f of x. If you can find this limit, you can tell me that the limit is equal to, let's say, L for limit, then you can say that there is going to be a horizontal asymptote with equation y equals L. So this is the process for us to find horizontal asymptotes. That's the relevance for limits to infinity. To see if we understood this well, it's pretty important, and to differentiate horizontal and vertical asymptotes, I'm going to show you one last picture in here. So I'm going to insert this picture. It's from our book. We stole it from the book. We have a pretty crazy graph in here, and I want to showcase in here the difference between horizontal and vertical asymptotes. Okay, so look, let's see. It should be pretty obvious in here that our graph has a vertical asymptote at, let's say, x equals 3. There are some others. There's one at x equals 0 and some others, but at x equals 3. Why is the vertical asymptote? What are the symptoms for the vertical asymptote? If you take the limit for this function, let's call it g of x, as you get close to 3 from either the left or from the right, this function is going to have to go to either positive or negative infinity. In this example, it will be to positive infinity. This is the telltale for a vertical asymptote. You get close to a specific value on the x-axis, the function grows to positive infinity or decreases to negative infinity. What about a horizontal asymptote? For a horizontal asymptote, we have one in here going to positive infinity, and we have a different one going to negative infinity. I want you to see that. So I'm going to say in here that what is the telltale for horizontal asymptotes? You have to take the limit of the function g of x, but now going to either positive infinity or going to negative infinity. If this limit exists, if you can find it, going to positive infinity is going to be 2. Then you're going to have a horizontal asymptote at y equals 2. Going to negative infinity, this other side, the limit is going to be negative 2. So then you're also going to have a horizontal asymptote at y equals negative 2. So you can have two different horizontal asymptotes. The other thing that is weird about horizontal asymptotes is that your graph can cross them. Look in here, in here, and in here, and in here, and look at these other points. So some people say that, well, you cannot cross a horizontal asymptote or an asymptote of the type. You can. What you cannot cross is a vertical asymptote. This is it for numerical and graphical ways to do limits to infinity. In the next video, I'll show you how to do it analytically.